Hello and welcome to another video of Grokking the coding interview series, where we are looking at the sliding window pattern, and in this video we'll have a look at longest substring with distinct characters, which is classified as a hard problem. Let's have a look at the problem statement, and from there we'll try to build an intuition around how we can go about implementing this problem. So given a string, find the length of the longest substring which has all distinct characters. So we cannot have any repeated characters. Let's have a look at the first example here. Here the longest substring with distinct characters is ABC, and if we see here, this string occurs in this substring, and yeah, if we look at any other segment, we do see a significant repetition. In this case, we can see that the longest substring is again AB, and in this case it can either be ABC or CDE, which both have distinct characters. So, I mean, at this point, we know that we have gone through the sliding window approach. We know that we have to start with a sliding window approach. Now, like the main condition which we have to evaluate while we are implementing such a solution is, what will be our mechanics of shrinking the window once we have encountered, say, a repetitive character in that window? Like what will be the idea around it, or what will be the logic around it? So let's take a look at the first example and see what we might want to accomplish. So in this case, we start with a sliding window of length 1. Then we'll see that, okay, and we'll also maintain the index of all the characters which we are encountering, and we see that we have another character of another repeating character, and we know that in our hash map we have already maintained indexes of these characters, so we see that this character already exists in that hash map. And in this case, what we would want to do, and our idea will be, we want to move the window start to an element later than where the repetition happened. So essentially what we want to do at this point is, we want, if the window start has already moved ahead, we essentially want to take the maximum of the window start at that point, or the index of this repeating character plus 1. So essentially our window start will move here, and we'll start exploring this combination from here on. I mean here, because we just want to retain one occurrence of this character. So essentially our window start will move here, and we'll start exploring our search for distinct character strings from here on. Hence, we'll go ahead and add ABC. And as soon as we encounter another character C, what we'll do is we'll shrink our window, and our window start will either be the maximum of the window start, or will be a maximum of window start if the window has already moved ahead, or the index of this character plus 1. So we'll end up being here again, and we can start our exploration here. Same will happen at the second occurrence of B, but the string ends, so we wouldn't really do anything at that point. So let's have a look at another example to just have the idea clear, and then we can jump on to implementing a working solution. So we start our exploration with ABC. We have not seen any repetitions. All is good. We come to C. We see a repetition. We move our start window to the previous index of C plus 1, which will be here. which will be the second C, and then we'll start our exploration. So you get the idea. As soon as we encounter a repetition, we only want to retain one of the characters for so if C is repeating, we only want to have one occurrence of C in that window, and this is how we want to move forward. So how would our implementation look like in this case? A lot of the components will exactly be the same as what we have been implementing for all the other problems in sliding window. We'll have a slight change where we want to keep a hash map. Okay, let's start implementing, and I'll explain this as we move forward with our implementation. Okay, so let's do. So char index is a hash map, which will be a new addition, where we want to keep the most recent index of all the characters which we are essentially traversing in the window. And we of course have the max len. We have window start, and these will be 0, 0 to start off with. And again, as the very similar exercise, we'll go ahead and iterate using the window end. Str and at this stage we have an element, and that element is simply, or we have a character, and that character is stir, and we index with the window end. And at this point, what we want to cross check is if this character is already in char index. If this character is not in, because if it is in char index, we do want to do subsequent operations. So a good idea as a first step would be to just check if it isn't in the char index. If it isn't in char index, then we'll just simply go ahead and put it in the char index. So, and the index will of course be window end. Now the else clause is an interesting one. As soon as we encounter a situation where we already have that character present in the char index, we know that this is a repetition of that character. So at this stage, first of all, I want to go ahead and get the max len, and there is one significant change here from all the previous implementations. So the max len will be max of max len and window end minus window start. And if you observe, I'm not adding a 1 here, and the reason I'm not adding a 1 here, because this window end which I have here, it already accounts for the repetition. So when I'm accounting for the max length, I don't want to account for that repetition. So I'll just just skip that element out in my calculation for the max length. So once I'm here, I want to find a logic for updating the window start. And as we spoke about it previously, that I mean, of course, if the window start has already moved ahead, I want to take, I mean, I want to say stay at window start. So for example, if I have not encountered any repetition, and the window start has moved ahead, I would want to take a max of window start, or I want to take char +1. So it would essentially satisfy the condition which we spoke about earlier, that I want to skip this index. So if I already have an existing index, so for example in this char index, I already have the index for the first occurrence of C. And what I want to do, as soon as I encounter it, I want to move the start window to the index of the first occurrence of C +1. And this is what I'm essentially accomplishing here. And this would essentially give me the answer I'm looking for. So I've been of course, I have been able to update the window start, which is the tricky part in the implementation. I have been able to extract the max len. I've been able to encounter, I've been able to address the situation where I want to remove the situation where I'm counting the second occurrence of that character as well. So let's go through this implementation and do a sanity check, and we'll run and see if our implementation is indeed correct or if we have any errors. To start off with, we have a char index hash map, we have max len window start for window end in range length of string. We extract the character from the string. If this character is not in character index, it means that we have not seen a previous occurrence of it, so we can simply go ahead and add this character index into the hash map. Otherwise, if we have already seen this character previously, we first of all want to extract the max length. We want to address the situation where we do not want to add 1, and we want to update the window start. And this should give us the answer which we are looking for. Let's try to run it and see if it is indeed the case. Okay, so our implementation is working fine. Let's quickly speak about the space and time complexity of the implementation. Speaking about the space complexity, we have a char index hash map, and essentially we could be effectively maintaining it for all the characters in the string. So this would be O of n, and we are iterating through all the elements of the string only once, and we do not have an internal loop which we had in the previous implementations. So the runtime complexity of the implementation will be O of n as well. Let's quickly cross check and see if we are right in those assumptions. This also means k, because in the worst case the whole string might not have any duplicate character, so the entire string will be added to the hash map. Having said that, since we expect a fixed set of characters in the input string, we can say of n fixed space. This is an interesting one. I did not know that. So our runtime complexity is fine. Our space complexity is a bit off, but it's again good to be wrong at this point and update ourselves. So the algorithm shows O of k, where k is the number of distinct characters in the input string. Okay, so essentially we impose a larger assumption that at max we can have like 26 characters. So this can be fixed space because there wouldn't be growth. I mean, It cannot grow beyond this. Okay, excellent. I hope you found the implementation clear enough and the explanation clear enough. Please feel free to reach out if you have any questions, if something was not clear. More than happy to improve. Until the next video, enjoy your day.